Good day, good afternoon, good evening to eCognition users or people that are interested in eCognition around the world. This is Keith Peterson. I'm the product manager for the Trimble eCognition software products, coming to you from Munich, Germany today. Welcome to this webinar, and it is entitled eCognition Essentials for Beginners. Today we are going to be talking about our eCognition Essentials product. But before we launch into the webinar, I'd just like to mention that we also have Christian Weise with us today. He is our eCognition market manager responsible for business development. And the way this webinar will work is you are all in listen-only mode, but you can use the question field within the tools to submit a question to us at any time during the webinar, and we will stop periodically to answer these questions. We'll give a brief introduction to eCognition Essentials, and then we'll dive right into a demonstration of the software, as you'll see in a few moments. So let's get on with it. First of all, an overview, what are we going to be talking about today? Like I said, first of all, what is eCognition in general for anybody that's new to our Trimble eCognition software. Then we'll look at the essential software itself. And then we'll go into how does this all work? And we're going to be showing you this based on a few examples. First of all, an example of what we call knowledge-based classification. I will talk about that when we come to it. And then supervised classification using machine learning within eCognition Essentials. And then, we'll end with a question and answer session. So any questions that maybe didn't get answered during the webinar itself, or something that hits you later in the webinar, we will take some time afterwards to discuss this. So what is eCognition? eCognition, first of all, I'm going to talk about the background here is we launched the eCognition suite. This is a very powerful advanced analysis software for the development of geospatial applications. And what we are really trying to do here is create or enable users with various tools to be able to create feature extraction or change detection solutions in order to transform this geospatial data in the form of images or point clouds and vector layers into geospatial information. So we're trying to go from this our real world through image data, maybe combine that with elevation data, and extract land cover maps, impervious surface maps, maybe even map individual objects in our data. So, as I said, this is an advanced analysis platform, a very horizontal solution that's available for a number of different applications. And where we've taken this is now in our various products is, of course, here I have the eCognition suite. This is, like I said, a development and analysis platform. We also have eCognition Essentials, which we will talk about here today. This is what we call generic remote sensing application. And we also offer vertical applications, which are really designed to analyze a specific problem. For example, the eCognition oil palm application for the analysis of oil palm plantations. And where we find ourselves with Essentials is this generic remote sensing application and a simplification of the tools that are available within eCognition Developer. So what are we doing? How does eCognition Essentials differ than, say, that the developer product that some of you may have heard of in the past or be used to using? Well, we are taking the concepts of eCognition and we're packaging them into an out-of-the-box solution, primarily geared towards land cover and change detection mapping solutions. And what we hope to do with this software, or what we've been doing with this software over the last several years, is provide an environment where users of any skill level can quickly utilize object-based image analysis techniques to create GIS-ready deliverables from their imagery. So again, we're transforming our geospatial image data into geospatial information within Essentials. What are the real benefits of a package like Essentials? Well, first of all, what we call low ramp-up time. If we think about a developer where you actually have to get in and create these rule sets, these image analysis workflows, we have packaged this in Essentials in a graphical user interface to perform these land cover mapping tasks on the imagery. So you no longer have to get down and actually physically program any type of text within a rule set or within a process tree within developer. You have to have no knowledge of eCognition developer in order to use and create these workflows in Essentials. This means we can get work done faster. We can jump right in, use the tools and the workflow that comes prepackaged in Essentials to create guided, automated workflows for effectively transforming our data into information. Yet we still have a number of flexible tools within Essentials. So the highlights, again, easy to use user interface. We have access to automated analysis tasks. So again, we can automate the image analysis workflow. We have a predefined and structured workflow steps that will guide users through, but again, they are flexible to a degree here, which we will see in the demonstrations. And Essentials provides, from our perspective, all the tools that are needed for a supervised classification, or as we also know now, a knowledge-based classification within the remote sensing market. And it also enables us to load image and thematic change detection workflows. So we can do change detection within Essentials as well. Some of the user interface controls and functionality that is available. We have a create projects dialog that will easily walk you through the creation of these projects that are needed for the image analysis. We can create objects based on GIS data. We can create objects based on, of course, the image data through multi-resolution segmentation or even a threshold segmentation within the parameters of our classification. We can execute supervised classification, threshold-based classification. So this means we have access to support vector machines, CART, random forest, nearest neighbor, these types of machine learning algorithms. We can execute, like I said, thematic change detection, but we can also do image-to-image change detection within Essentials. On top of that, we can, of course, edit our results within Essentials if that is deemed necessary. There are tools for doing manual editing. There are also a number of tools available for reshaping our results or refining these image objects, as we call them. So object merge, smoothing, applying minimum mapping units, for example. We also offer the ability to do accuracy assessment. We want to know how accurate our classification was, of course. So this has been offered a very nice, easy tool, which we'll see in our supervised classification demonstration later. We can also create reports within Essentials. And finally, we want to get this information out so we can create vector layers within Essentials. And when we create any information in Essentials, we need to eventually export it to use in, say, a GIS or any other type of mapping environment. So we have the tools to export these results. And these are all at your fingertips. And we will see how those can be added in the workflow and adjusted accordingly. So workflow, you can combine all these tools as you like within Essentials. Like I said, it is flexible. You will see the default workflow when you open up the software. But keep in mind, you can always add, remove, and shuffle these tools as you see fit and as is required by your analysis needs. We also have the ability to submit projects to eCognition Server from Essentials. So you can configure these workflows and send them in batch for processing. And this allows the analysis without manual intervention, like I said, in batch mode on a dedicated server hardware. So again, that means you won't be bogging down your local computer options here with big and maybe jobs that take longer to process. This allows you to increase your production and also parallel processing, so you can send multiple jobs at one time. And this, of course, will then save time over the course, so you could actually send jobs to the server while the user queues up the next project and configures that, and makes for just more efficient use and generation of these products. So that is eCognition Essentials in a nutshell. Like I said, we've taken what we feel is core functionality from eCognition Developer. We've packaged it in an easy-to-use graphical user interface and made it flexible for your needs, particularly geared towards land cover mapping applications and with a leaning towards satellite-based land cover mapping applications. But as you'll see, we can support other data formats. That being said, before we jump into the demonstrations, are there any questions that may have come up about Essentials? And maybe I flew over something quickly, how it differs then, say, from a developer, or just questions in general to how it can be used at this point?
There was just one question, if eCognition Essentials supports LiDAR data in the LS format directly. And here I gave already the answer that we're supporting just image data with Essentials. But if the customer converts the LiDAR data into a raster, then you can directly use it as input data inside Essentials.
Yes, absolutely correct. So LiDAR data or point cloud data in LAS or LAZ formats is not supported by Essentials. I will point out, though, it is supported by eCognition Developer. But in Essentials, we support, say, the products that are derived from such data sets, digital elevation model, digital terrain models. And as you'll see in our first example, we're going to be working with some of this rasterized point cloud data. So it's a good thing to keep in mind. All right. So the demonstrations, what are we going to show you today? I'm going to start out with a knowledge-based classification. We're going to be looking at a forest canopy mapping. The goal here is to automatically extract forest canopy with various crown height classes from our input data. And as input data, we have, like I said, eCognition Essentials was geared towards satellite products, imagery, but we can support other formats. Here we're actually going to be using an aerial imagery data set, RGB plus near-infrared image, as well as an NDSM. So this NDSM, I can say it was derived outside of eCognition Essentials from a LiDAR data set. So it's been rasterized, and we can use that then in eCognition Essentials. So I'm going to just get out of the PowerPoint and we'll open up our Essentials. This is what eCognition Essentials looks like. So anybody who's familiar with Developer, you'll notice a completely different look and feel here. Like I said, we're using a graphical user interface to launch and command these tools. And the first, we see our workflow here on the left-hand side. And by default, when you open the software, you are automatically in this create, modify, project action, as we call it. And this will walk you through the creation of your project. So this action is highlighted. I can see then all the individual elements of this action down here. And the first thing I want to do is actually import data into eCognition Essentials. So I'm going to create a new project. And here is my data for this. I'm going to create, first of all, select this airborne RGB NIR TIFF. Select OK. And this will load into the project. And as I mentioned, we also have elevation data to go with that, an NDSM. So I can also click and add another layer here through Add Layer. I'll select that NDSM, say OK. This is now available within the project. If I look up here into this Analysis Builder toolbar, I see a number of different options, of course, tools for navigating throughout the image, cursors, pan, zoom in, zoom out, zoom to extent. We also have here a list of the layers that are available at the moment. It's just labeled RGB 1 through 4, and I see down here also my NDSM is available. But we can make this even smarter in Essentials. Now that I have my data initially loaded, we can continue coming down through these tasks. So first of all, I have this results folder. Here I can define immediately where I would like Essentials to store the results that are going to be created, so eventually shape files or whatnot. By default, it's set up to the desktop. I'm just going to leave that, but you can browse and set it to any location that you'd like. You also have the option to adjust the resolution of your input data, so we can downscale this if we like. I'm going to stay and work with full resolution. In addition, if we're maybe experimenting or we don't need the whole area for analysis, we can select a region of interest to work on within Essentials. Now, by default, it's set to complete scene, as we say here. I can also add a user-defined region of interest, so I can select that. I can then take the rectangle tool, and I can simply drag and drop this over the area that I would like to analyze and say, accept that area. Now my analysis will be confined to this particular region of interest. In addition, I can draw polygons. I can go back and delete a region of interest if I don't, I'm not happy with that. And also, I should mention, you can add the region of interest from a layer. That means if I have a shapefile that contains a polygon with my region of interest, I can load that automatically from the shapefile. Again, to load that shapefile, just simply click on Add Layer and navigate to the shapefile that you'd like to add to the project. The next step here is to assign what we call layer aliases. What layer belongs to blue, green, red, near infrared, etc. You see that we can also do this for DTMs and DSMs. So if a user has that digital terrain model, that digital surface model derived from a point cloud, for example, they can load those here, and we will automatically generate your NDSM, that normalized digital surface model, from those two products. In this case, I have a pre-processed, if you will, NDSM, so I will just leave those to not assigned because I do not have a dedicated DTM and DSM within this project. But I do have multispectral data, and I would like to tell eCognition Essentials which band corresponds to which spectral band here. So I know that my band 1 is blue, band 2 is green, band 3 is my red, and I also have my near infrared here, so I will assign that to the band 4. How do I know this? Well, I have that information from my data provider ahead of time, and can make those decisions. Once I have this, we can automatically display our data in RGB, for example. Go back up to these layer mixing. So we see we automatically calculate the RGB as well as a color infrared mix here. We can also create additional layers within Essentials. So if you hover over one of these tools within Essentials, you'll see in the description field in the lower left-hand corner, what is this tool going to do? Well, you see here we're going to calculate an NDSI, so that's a soil index. We're going to calculate the NDVI, vegetation index, and NDWI, which is the water index. And if you had the DTM and DSM, the NDSM. Note, for some of these indices, you require the near infrared data. So we will click to create these layers. And now let's see how this worked. We have our NDVI, for example, and this is looking nice for our image. If I hover over, I can, with the mouse, I can see those NDVI values here.
Keith, there's a question here during the webinar concerning what exactly is an NDSM layer. Maybe you can explain it.
NDSM, good question. It's what we call a normalized digital surface model, and in effect, it's bringing it's the elevation above ground of any elevated object. So it's your DTM minus your DSM, and it's just an arithmetic function. So then we would see, instead of the tree height plus its elevation, we would see simply the tree height above ground. So if we go to that NDSM layer, I think we can show that very nicely. Actually, we can see how this works in a split screen. So on one side, I will display my NDSM layer here, and we can zoom into this, and we can see that the ground all has values very close to 0, equal to 0, whereas our trees, for example, have elevated values 21. It's not 521 for its ground of elevation plus the object's height. It's the height above ground in this case. Okay, hopefully we were able to answer your question. Zoom back out to extents here. So once I have created these layers, or I fulfill the minimum requirements for an action within Essentials, you'll see we get a check mark here. That means I've fulfilled the minimum requirements and I can move on to the next step in analysis. So for us, we are dealing with image objects. So we need to create image objects. We do that through what is called segmentation. And within eCognition Essentials, we've given you the multi-resolution segmentation algorithm. It is one of the most powerful segmentation algorithms for the analysis of remote sensing data, and is very well suited to the needs of eCognition Essentials. So the user can determine a scale parameter that will govern the heterogeneity of pixels within an image object. I'm going to choose something like 30, and we can simply execute this, and what you'll see is that since I have defined a region of interest, we will only create image objects within my my predefined region of interest, not within the entire scene. Okay, so runs rather quickly. We can zoom in, take a look at these image objects, see how they correspond to features within our image. So we have image objects that nicely correspond to our buildings, as well as our trees and various features here. We can click on those image objects to select them. So the next thing we want to do now that we have image objects is we want to start to describe these image objects. We want to classify them and assign them to a class that we can use to describe these features that we're looking for. So by default, in our workflow, we see the supervised classification, object merge, accuracy assessment, and export. These are the default tools available in the workflow, but you also notice these big minus marks here. We can go and come in and say, oh, I'm going to knock all of these out because I would like to create the workflow as I go along, and it's not going to be the default. So like I said, you have amount of flexibility here within Essentials. So I'm now going to add a new action to this workflow. And I click this plus symbol, I open the Add Actions dialog, and what I'm going to be doing here is what we call threshold segmentation or classification. So I can just highlight that, say Add, close this dialog. And now I can start to classify my image objects. So how do I want to address these? First of all, I want to, this specifies the working domain. What image objects am I going to be looking at? Well, right now, I want to look at all image objects. And now, what layer do I want to use to classify my image objects? So like I said, we are interested in forest canopy classes, specifically forest canopy by height. And now I need to use my knowledge as a remote sensing expert. How can we best describe forest in terms of the data that we have available to us? So for me, I know that forest is going to be elevated above ground. Remember, I have that NDSM that has those heights above ground. So my first step is going to be to select that NDSM layer. And I'm going to just add a particular threshold here. I'm going to say anything greater than 0.25 meters is going to be considered elevated in this analysis. Remember, it's knowledge-based classification, so my expert knowledge is determining these thresholds and class descriptions. Next thing I need to do is say, tell eCognition Essentials, what should I do with any image objects that fulfill this class description? Elevation greater than 0.25 meters. So I want to put them into a class. I'm going to call this class Elevated and select a color for this class. It can be anything you like, maybe something like orangey red. Say OK. So now I have this class, and what eCognition Essentials is, well, we're going to split this image between dark objects and bright objects. And this is where it's very nice to see this NDSM in the background. If we click on one of these forested objects, I immediately see it is bright. Its values are high. The higher those values are, the brighter and whiter they will appear in the visualization. So I'm going to say all dark objects, essentially anything below 0.25 in the NDSM, are going to stay unclassified. I'm not interested in those. And now I'm going to put everything that's bright into my elevated class. And we will execute this, and we immediately see the results. So if I go back to my imagery, I can see that we've classified the forest area as elevated, but we also have other elevated features in this class. So we also have these buildings, and this is going to be addressed in the next step. Now, I've classified the elevation, or elevated objects, and now I want to add an additional classification step here to restrict what's going to be included as forest. So again, I can click the plus symbol. I'm again going to be using this threshold segmentation and classification algorithm. Click add. It is dropped right here in sequential order. Remember, this will run from top to bottom. So now I'm within this action. Because I've already classified elevated objects, now I'm interested in filtering out that class. So I want to work only on elevated objects with this next action. That will mean if I have lots and lots of other objects out there, that I can be more efficient in processing and more efficient in terms of my class description, focusing purely on elevated image objects. Next, how can I differentiate between forest and these buildings that have also been classified as elevated? Well, NDSM, or my elevation data, is not going to be well suited for that. But we also have these indices, as you remember. So we also have a vegetation index, NDVI. This gives us a sense of whether an object is vegetation or not. Remember, NDVI goes from a value of -1 to 1. The higher that value is, the more likely or vibrant, healthy the vegetation is. So I've selected to use my NDVI layer when describing these objects. I'm just going to choose a threshold of 0 here. So anything greater than 0 will be considered elevated vegetation, if you will. Now, where do I want to put these objects that meet the threshold? Again, I need to create a class. So I'm going to create a class. I'm going to call it forest. Give this a color. I'm going to give it some off green. And again, I have to come in and determine what class for dark, what for bright. So I'm going to take any of these low NDVIs, and I'm going to just toss them out. I'm going to put them into this the unclassified class, and any elevated object that meets my NDVI criteria will be put into a forest class. Again, we execute this, and what we see now is that we have removed those buildings from the classification, and now our forest is classified here as a forest. But we're not quite to the point we want it to be. Remember, I said we want to classify these tree crowns based on their crown height. So we need to add a couple more steps here. We're going to split them into, say, three categories. And again, this is a very strong tool to be using within Essentials. We're going to go back to our classification tool, add another one of these, and now just have to drop this down so we can see some more. We can now look at splitting up this forest class into its various canopy heights. So again, I want to focus only on forest objects. This time, looking at canopy heights, we have that elevation data, so I'm going to be using our NDSM layer to describe these. And the first threshold I'm going to look at is 15, so anything greater than 15 meters, we will put into a class, and we're going to call this class forest greater than 15 meters. And we can give it a nice color here. Say okay. And now, what do I want to do with my image object? In this case, is going to be a little bit different. I would like to still maintain my forest class. Right now, I just want to take those forested objects that are greater than 15 meters and put them into a dedicated forest canopy height class. So class for dark objects, keep everything that didn't meet that criteria as classified as forest. And I'm putting the bright objects into the class forest greater than 15 meters. We can execute this, and we start to see we're getting some of these canopies to appear here. Okay. Next step, you might be catching on here. Again, we want to classify, so I'm going to this time select my forest class. Still using that NDSM. This time I'm interested in anything greater than 10 meters. And we will say forest, and now I'll say 10 to 15 meters. Assign it nice color. As you can see, I'm going to create sort of a graduated color scheme here within Essentials. Setting it up the same way as before, so keeping those dark objects classified as forest, and this time anything bright is going to be 10 to 15 meters. We can launch this, and you can see we're expanding the classification of these forest crowns. Next, again, we'll do a next class, and once again, forested objects. And this time I'm interested in anything greater than 5 meters. So assign that to a class, forest 5 to 10 meters. And give it another color in our ramp here. Again, maintaining that initial forest classification or forest objects, and now assign this here. So we could go on and continue doing this for any types, any type of scheme that you'd like, any breaks that you'd like to see. One thing to point out now is that we have these classes. We also have a legend available over here on the right that we can always go back and reference if we're not sure what an image object is. But if you hover over an image object, not only are you seeing here the individual RGB values, because that's the layer mix that we have, but it also say this object is currently in the forest class. If the view is too limited for you, we can always pin these off to the side. We can even get rid of the sample information. We're not doing a supervised classification here. So you can always customize these views to use the whole view window. All right. So now I've created a bunch of objects. They are still individual image objects. If I come in and want to look at the individual object outlines here, we can certainly do that. And the next step will be to merge these image objects, so it's essentially performing a class-based dissolve if anybody's coming from a GIS world. So this is what we're calling object refinement, or maybe you want to say I'm refining my results. So we see here we have an object merge action. I will add that. Close. You have the ability to just say simply merge all classes based on on all image objects based on class, or you can apply the merge to selected classes only. In this case, I'm going to merge all classes. Apply this. So now when I select that image object, it's not going to be only see here my outlines that I've gotten rid of the individual initial crown outlines. It's one large image object for those neighboring objects. And we can take this refinement a step further. Add another action here, and we would like to smooth objects. As you can see, these are jagged outlines that reflect the high resolution of the pixels. Maybe I want just a smoother tree or class outline. Again, I can select to run this on all classes or just on specific classes, and then you have this scale. I'm going to choose something like scale 5 to apply here. Don't want to be too drastic with my smoothing. And now I'm going to smooth all these outlines, and you can see then those results very nicely here. All right, we still have, if we zoom way in, we still see these, so this pixelated edge. That's because we have to maintain the edge, the initial pixel border. We can't cut a pixel in half with this particular smoothing tool. Finally, we're happy with our results, and we'd like to export these. So I'll add that export action to the workflow. We'll take a look at this. We can export various types. We can export object vectors. If we had an existing vector layer that we created within Essentials, we could export that. We can export also existing rasters. So if I create that NDVI image product within eCognition Essentials, I would like that as an individual TIFF or JPEG or something outside of eCognition Essentials. We can export that as well. And we can also use various attributes here. So we're going to export these with the class name, and this will be exported to that folder that we defined in the initial project creation, and it'll be put into a subfolder called results. Because I'm exporting the vectors, I can select either a shape file, or as we see in the dropdown, we can also save to a file geodatabase. And then finally, just simply click export, and you can see it's checked off, it's complete. We could then go and open this up in a GIS. The last thing to mention is, wonderful, I've created this image analysis workflow. I'd like to then apply this to other images, but do I have to go through creating these, setting up this workflow each individual time? No, you do not. You can save what we call this configuration file. This will save that workflow configuration, and when you create your next project, you load this configuration, and you can simply execute that on the next image without having to reconfigure all the parameters that you've done here. So you can save a lot of time and quickly get the work done. Christian, this wraps up knowledge-based classification within eCognition. Are there any questions out there?
Yeah, of course. There are some general questions. The first is concerning a trial version or a version to play around with the software. Is this available for interested customer?
Yes, we have a free trial version of eCognition Essentials on our website, www.ecognition.com, and you will see immediately the trial tab there. Just go to that trial tab, and you can download the free trial for Essentials.
Wonderful. And there are also several questions. Is it possible to get a recorded copy of this webinar after the webinar?
Yes, all webinars that we do, our monthly webinar series, they are all recorded, and they are available in the Trimble Geospatial Webinar Archive. So the same place you went to register for this webinar, if you just scroll down on that site, you'll see all the various webinars that the Trimble Geospatial team has put out over the last several years, and you can watch this webinar over and over again. If you maybe missed something, forgot something, you can always go back and access it. Yes.
Cool. And also, if you download the trial version, you will get also download links for a demonstration data set, exactly the data set here, for instance, what Keith is currently using, so that you can also play around with the same data following the steps showed in the webinar. And there's also a very specific question from a user who tried the trial version, and he is asking, is there a way to change the layer mixing in Essentials? We have the default values, or is there also a way to change the equalization settings or things like that?
Sure. So let me go a step back and just turn off the image object outline. So now we're back to our initial image here. If you go to this drop down where we see RGB, we can also come in and customize layer mixing and equalizing within Essentials. So if I want something very specific, we can come in and do this. So you can access this mixing. The way it works is if you want to turn on, activate a layer, essentially, we can set those bubbles here. So maybe I want to look at RGB plus my near infrared in the green, for example. This can be done. You can also set various equalization parameters. So we can set something like a standard deviation. I've always liked this one. And you can get as specific as you like through this edit image layer mixing dialog. So again, that's just coming through the image layer drop down, customize layer mixing and equalizing, and you can do that. Good question.
Wonderful. Very good. And there are also several questions concerning the scale parameter in the multi-resolution segmentation. And here I would like to comment that the output of the segmentation are the starting point of the analysis. That means the segments doesn't to be perfect. That means they have to be small enough so that we can classify all needed objects. And during the process to classify objects and reshape and merge and reclassify objects, we optimize the size of the object step by step so that we convert the initial building block object to the final GIS object. That means don't spend too much time at the beginning to identify the perfect scale parameter. Please be sure to create small enough objects. If the object is too big, that it's bigger than the building or than an agriculture field or tree, then it's not a good object. That means starting with the default values, increase and decrease the scale parameter to get small enough objects. That's a good recommendation from our side. Technically, the scale parameter is a standard deviation of an homology value based on color and shape differences, and you will find a lot of scientific papers in the internet how exactly the scale parameter is be calculated and used.
Right. I think the last comment from my side is there is no golden rule for a scale parameter. The scale parameter of 20 is not always going to be applicable. It will depend on your data. It'll depend on the objects you're looking for. So don't think that we always have to use the scale parameter of 30 that I've demonstrated here. Experiment with it based on your data and then what you're looking to classify. And like Christian said, don't get hung up on it. As you've seen here, I create initial image objects and I change them throughout the workflow. So great. If that's it, I'm going to move on now for the sake of time to our next example. We're going to be looking at supervised classification, so machine learning within eCognition Essentials, we're going to look at land cover classification. The goal is to do an automated land cover classification here. This time we're working with satellite data, again, RGB with near infrared. And we also have a shapefile that I will load that has our validation data in it. So, jump right back into Essentials. One thing you'll notice is that I have already fulfilled the first two actions of this workflow. That's because to spare some time, I've created this project ahead of time, just like we did before, by loading the data, defining my image layer aliases and bands. And then I've performed the multi-resolution segmentation, which took just a few minutes, and we can skip over that as we've seen that step already in the initial exercise. So the default workflow actually works very nicely here. I want to perform a supervised classification. I see that the supervised classification tab is the next one that is active here. And I can simply click on this, and I see the tools available for the supervised classification. One thing I just want to check is if my samples or my validation samples are available. I see that they are before I continue. So getting back now to the supervised classification, I need to define an input class. If I was going to set a working domain, we're going to use unclassified here. But what I need to do for supervised classification is I first need sample data. So within eCognition, you have a number of tools available for getting these samples. We can load them from a statistics table, for example. We can add them manually, and we can also import them from a shapefile. For this exercise, I'm going to demonstrate how you would add these manually. And by the way, you can also combine these methods. You can add them from a shapefile. And if it wasn't representative enough, I can also supplement that with manual samples as well. So I'm going to add my training samples manually. How do I do this? Well, first of all, I need to create the classes that I want to assign these training samples to. So we're going to classify grassland, and we'll just call it, give that greenish color. I want to also classify what we're going to call build up, and I am also going to look at water. And finally, we will classify forest. So again, we can take our colors, get as detailed as you want with these color schemes. You can come in and customize it as much as you like. So I now have created the 4 classes that I am eventually interested in looking for. The next thing I need to do is assign some samples to these classes. So I'll zoom in to my image. I'll start with water because that's pretty straightforward. And I can simply I select the class I would like to collect a sample for. So I've selected water, and I come over here. You notice the icon and the cursor is a little different, and I can simply click on a water object. Pan here. If I want, I can draw a line, and any image object that is intersected will be assigned to the sample data for water. You can change those views again here, so it might be easier in terms of vegetation going to an infrared view. So I'll come in. Next class we want maybe is build up, and I'm considering a lot of different stuff here. Build up these white tanks, we have roads, we have buildings over here, different shades, docks, and we can again select some representative samples. I'm not going to spend too much time here. It's demonstrating this, but obviously the cleaner and more effective your sample data set is, the better your results will be. Next, grassland. Looks a little hard here. You have to know where you're looking. In this case, anybody maybe from North America or Japan might know this is a baseball stadium, so the outfield is typically grass. Also see it based on just its smoother texture as compared to these forested areas. There's another excellent place in this image, for example, to find grass, or if you have the luxury in your area, golf courses. So we can see nicely our fairways and greens. Looking very vibrant there. We'll assign those to our grass sample class. And finally, we have forest, and we have this forested area here. We'll try and pick up some of the different variations in the forested area. Remember, I can also just kind of swipe to get those. And you'll notice if I lose track, how many samples did I create? Well, in this sample information dialog in the lower right-hand corner, you'll get a good representation of the number of objects that have been assigned to each class. It'll also list what is currently in your feature space for this. So as you can see, I've created 9 samples for water, 13 for buildup, 10 for 9 for grassland, 10 for water, and 20 for forest. And you can get as many as you like here. Once I'm done assigning or creating these sample objects, you have the ability, if I mistakenly put an object into the forest class, for example, I can always come back. I can delete a sample. Maybe I didn't want that object as forest sample, so I can remove it from there. I can also delete all the samples from a project. If I really don't want them and do that, you can delete the table, or you can also export these samples as a shapefile or as a table that you can use in other projects. If we come down farther in the supervised classification action, we can see the classifier parameters. Well, first thing we need to decide is what classifier algorithm models do I want to use. As we can see, we offer several here in eCognition Essentials: Bayes, KNN, which is our nearest neighbor, support vector machine, decision tree, and random trees, which is what most people associate with random forest. So I'm going to choose a support vector machine here. And next, I just have to tell Essentials where are my sample objects coming from. In this case, they are object-based. If I had imported them from a shapefile, oops, sorry, click this, I could specify that layer here. The feature space. Well, how can we find that? Well, we can click here, get an example of what's in our feature space, what features are available for it. By default, we're using the various indices that are created at the outset, as well as each individual band here. We can, of course, deselect them or get more specific here. As you can see, these are a list of available features. So we also have things like a mean difference to neighbors that we could also integrate into our feature space. I'm going to leave the defaults here. You see then, if I change these, the feature space features would then be listed here. Now I've set up the supervised classification parameters, and now I simply click classify, and I'll do the model training and application in a one-step here. So we can zoom back out to our entire map, and we can see nicely what we've classified based on our training samples, these 4 classes within the entire image. And it looks pretty good here. I see one mistake right off is that the infield in my baseball stadium, because it was very dark and shadowy, has been classified as water. So, like I said, there are manual editing capabilities available within Essentials. So I just click on that plus symbol again, say manual editing, click add, and close that up. And now if I come into this manual editing, I can come down and I can say, well, that baseball field, maybe we'd rather have that classified as build-up, and I can simply select build-up from the object classification and then click the image object here. Also see maybe some mistakes here in forest classification, so I can come in and correct those as I see fit. You can also undo these. So if you said, "Ooh, I made some mistakes in the manual classification," you can undo and get back to where you had started. Next thing I'd like to do is the image object refinement. So we saw this action before. I'm going to do an object merge. Had it already in my menu, but we can remove it here if it's double. And I'm going to merge all classes now. And we'll see those effects in a few moments. So my image objects or my classes have now been merged. Zoom back out. And one thing I notice in this particular example, it's very nice. I can see that we have some pretty small image objects out here. Not that they're necessarily incorrect, but there are some boats out on the water. I might be interested in objects of this size. So another great refinement action available within Essentials is minimum mapping unit, to apply this minimum mapping unit here. So I can apply this to all classes. I can also define specific classes that I would like to apply minimum mapping unit to. And we simply enter a value here. Remember the minimum mapping unit, as it says in the description, is in pixels. So remember your resolution when doing this. So maybe we'll try something like, we'll make it so we can see it, let's say 400. So if we have objects less than 400 pixels in size, it will be removed from the classification, and we use some neighborhood relationships. Specifically, it's border relationship to a neighboring object, and how it's going to be swallowed by that neighboring object. So we can apply this, and as you can see, we've removed some of those small boats from our classification. Didn't need those. As you can see, we still have some big ones out here in the harbor, though. So with this data set, remember I said I loaded a shapefile that contains, for me, my validation data. We can actually display that validation data here. And you see these little crosshairs. So this is where we had some maybe GPS points out and around. And now we can use this validation data perform an accuracy assessment within eCognition. So again, in this task, we select that layer that contains my validation data, and I will then define, well, what attribute. This file is rather simple, it only has one, the class name. That's what we're going to use to compare the results. And we can execute this. It'll create a table or the data where we can put in CSV or HTML formats. And we'll let this run. And then we also see in our accuracy assessment window down here, we automatically get our matrix of users and producers accuracy. So it looks pretty good here. Build up, we have some confusion, a lot of variation within the samples that I took here. But for the most part, this with a nice overall accuracy of over 90% here, without too much effort on my part, as you could see. And finally, we can again export these results out of eCognition into a vector and for GIS, for example. So Christian, any questions about supervised classification out there?
Yeah, there are several questions concerning the advanced parameter for the supervised classification action. we started here in this example with the default one, and you have to go back, then the people can see. I think that there was a way to change the advanced settings. I'm not 100% sure. Let's play around.
Yeah, let's go back.
Undo. No, undo in the supervised classification.
Oh, sorry, I'm doing this one. So here we go. Undo supervised classification. So let's take a look then.
And there's a checkbox, I believe so.
Settings, yeah. So advanced settings. Yeah. So with these various classification algorithms, you have some what we call advanced settings for a support vector machine. What type of so the kernel that you'd like to use, a linear RBF. You also have these C value. If I were to go into something like a random tree, there are a number of different advanced settings that you can set up here, such as the depth, the minimum sample count, max categories, things that are standard settings within these types of classifier models. So that's what the advanced settings would give you access to. If you're not interested in say, applying any of those advanced settings, then you would essentially set your feature space and accept the default settings for that particular algorithm, the classifier algorithm.
Perfect. Because we are offering some meaningful default settings using the different algorithms. But if you are an advanced user, you can tweak the parameters, of course. There was also another question, if we can visualize the input shapefile used to train the machine learning classifier in eCognition Essentials.
Yes. So if you have any shapefile that you'd like to visualize, this one happens to be called training samples, but in this case I used it to validate my data set. So I can simply select that. Like for the image layers, you also have a customized vector display. So if I open that, I could have multiple vector files available here, and I can click to show those. You'll notice those little crosshairs in the background get turned off. I can increase the size of those from here. Maybe you can see them better now. I can change the color and even transparency. So if I had polygons, for example, I could set a fill color, an outline color, and the transparency, as well as using drag and drop to select the order of drawing here if multiple shapefiles were loaded.
Wonderful. There's the question again, if a recorded copy will be available after the webinar. Yes, of course. You will find the recorded session on our geospatial.trimble.com Power Hour webinar site, or maybe you will get also automatically an email with the recorded information. But here I'm not so sure.
Yes, again, the webinar is recorded, correct.
So
yeah, if we'll get back to the presentation, if there's nothing else there on the software. So we've gone through the demonstrations. Just to summarize, eCognition Essentials, we consider this an entry-level product for remote sensing professionals and GIS experts. It allows you to quickly leverage object-based image analysis tools without having to learn how to create rule sets and how the intricacies of a very powerful software like eCognition Developer works. It's a standalone application with straightforward workflows. You can also use it as a click and classify tool and very easily create these GIS-ready deliverables. That was our goal with Essentials, and those are the tools that we feel as remote sensing experts are the essential tools for, say, the land cover classifications and things of that nature. So that being said, we're just over the hour mark here, but if there are any more questions out there that we haven't answered so far, we can take a few moments and cover those. Christian?
Yeah, we have more or less answered all of the questions. And
oh, great.
That's fine.
And if something comes up after this webinar, I would encourage people that are interested in Essentials. Again, there is a free trial available. You can go to our website, www.ecognition.com, and find the free trial for Essentials, as well as Developer. And you can download that. You'll have access to some demonstration data packages. But if you have any questions, you can reach out to us at any time. I encourage people to go through our support network. So you can write an email, support@ecognition.com, and our support engineers will get back to you with answers and any solutions to issues that you may have. And that being said, I'd like to thank everybody for your time today. Again, my name is Keith Peterson. I'm the product manager for our Trimble eCognition software products. And as you see here, you can also reach out to me directly. But if it's maybe say a support-related question, please contact support, as I am not always in the office and able to answer emails quickly. So thank you again for attending, and feel free to contact us. I hope you enjoyed this webinar. Stay tuned for our upcoming monthly webinars for September. Topic is still to be decided, but we're back from our summer break, and we're ready to continue the monthly series. Thank you, have a good day, and see you next time.